Okay, hi folks, it's me again. I've got a few questions here just to go over with you on forces in two dimensions. I've took these off the sheet they've put in the shared drive for you. They're not too hard, so it won't take too long. I'm looking forward to actually seeing, inverted commas, you all on Teams next week. But anyway, and I apologise for the lack of Lego figure on my last sheet as well. Someone picked up on that. So I will give you a particularly cool one today, hopefully to make up for that. Okay, this question here, so what have we got? These are the ones on the sheet anyway that you'll see, but again, not too bad. You've got two forces here, x going in the horizontal direction, 3x going in the vertical direction, both in newtons. They have a resultant that has a magnitude of 6 newtons, and you've got to find out what x is. My take on this would be, I'll just rearrange that slightly actually, but you'll see why, because you've got one sort of going up, one going across, so basically the resultant's going to go up that way. So if you think about it, it's probably easier just to draw them in terms of something like this, where your resultant there is 6. You can see the 3x going up there and the x going across there. So if you do that, then you can see you've got this right angle triangle. You can apply a bit of Pythagoras to it. So x squared add 3x all squared is going to equal 6 squared. And so if we do that, we've got x squared of 9x squared equals 36. So 10x squared equals 36. X squared is 3.6. And so we can therefore work out what x is. Give me the square root of that. Let me have a look. Square root of 3.6 gives us 1.897, so 1.9. So that's the first bit there, not too bad. Find the angle the resultant makes with the smaller force. So which angle we're trying to work out? Well, with the smaller force, that's the x, and so we're ideally going to work out this angle here. Just mark it on there. That's the angle we're looking for. So we'll just use trigonometry. So if we use tan, we can see, and that will allow us to cancel out the x's. So tan, just mark that as theta out there. So tan of theta is going to be 3x divided by x, which of course cancels the x's nicely, which is 3. And so if we shift tan 3, no, I don't know what it is, 71.6. So 71.6 degrees. And there we go, we found out what the angle is. Okay, the next question. Particle rests on a smooth horizontal plane. The particle is in equilibrium under the action of 3 forces, minus 3i plus 4j, 21i minus 7j, and r newtons. I'm not a big fan of i's and j's, you know, I like column vectors rather than that. But what we're going to do is find out r in terms of I and j. But we use a bit of common sense on this one, because if you think about it, you've got horizontal and vertical components. Currently, you've got minus 3, so it's going left by 3, that force. This one's going right by 3. So all I know is if it's in equilibrium, all of the horizontal forces have got to cancel out. So if we sort of let r equal, let's call it ai plus bj, just for argument's sake, I then know that minus 3 add 21 add a all have to equal 0. And so minus 3 add 21 is minus 18. It's 18. So a has to therefore equal minus 18. And I can do the same for this one here in terms of the vertical. So for b, we've got 4 going up there. I've got minus 7, and I've got my b. And so they all have to equal 0 if they're in equilibrium. And so minus 3 adds something. So b has to be equal to 3. And so straight away you've worked out what this is. So therefore r is equal to minus 18i plus 3j. Okay, find the magnitude of r and the angle between r and the I direction. Again, very similar to previously. Now I know what it is. I've got the 3 and the minus 18. So it's going left by 18, up by 3. I'm just going to sketch it out. Not exactly to scale, but approximately to scale. There we go. And so if I just put 90 degrees in there, I've got my triangle. So it's going up by 3, it's going left by 18. So the resultant force is going to go that way for the r. I'm working at the angle between r and the I direction, so I'm going to work out this one here. So again, we've just got a trigonometric ratio, tan theta, label it theta, is equal to 3/18. And so if I do that, just shift tan that, so shift tan 3 divided by 18, that gives me 9.46. So theta is equal to 9.5 degrees. What we've got to do is make sure we read this carefully, though. The question says find the angle between r and the I direction. Don't forget that the I direction is that way, so we ideally want to work out that angle there. So that's going to be 170.5 degrees. And there we go. Okay, so we've got all the information in that one. And the third question, the final one, again, I said these weren't too hard actually, but they're not supposed to be, don't things that are too hard. This one, question 9, which I'm still on the same sheet. Forces P and Q are given in newtons by P is 12I minus 5J, Q is 16I plus 1.5J. Write down the force P add Q and show it's parallel to 8I minus J. Okay, so if we do that, P add Q is going to be equal to, so we've got 12I plus 16I, which is going to be 28I, and we've got minus 5J plus 1.5J, that's minus 3.5J. Okay, and how are we going to show that's parallel to that? And you're going to be like, nice factors here. Nothing really going on with the 8 and 28 apparently, but the 3, 4, 5 and the 1, if we just factorise and take out the 3.5, we can see this. So 3.5, open brackets, we end up with 8I minus J. And so we can see we've got a scalar multiplied by that vector there. So therefore it's going to be parallel. Okay. Show that the force 3P add 10Q acts in horizontal direction. So 3P add 10Q. If we do that, what does that give us? 3P. So we've got 3 lots of 12I minus 5J plus 10 lots of Q, which was 16I plus 1.5J. Woohoo! 3 12s, 36I minus 15J. Then we've got plus 160I, and then we've got plus 15J. Oh, okay. Wow, the J is going to cancel, which is nice. That's going to give us 195I, and that's great. And so we've got no component of J, and so therefore it's going to be horizontal. So it's just talking in terms of I. So these were quite straightforward. And then, I do like her, she's quite cool. All right, a particle is in equilibrium under forces Kp, not crisps, 3Q, and its weight W. Show that K is minus 4 and find the mass of the particle. This is probably the hardest question of all of them, all right? It's not that exciting. So we've got a box, all right? It's in equilibrium. Well, it's going to be a box in my world anyway. Put that there. It has weight W, so we'll put the W going down there. Kp, all right? So you know P is 12I minus 5J, so across and down. So my default would be to write Kp sort of down like this way here, okay? That's how I would probably do it. We don't know it is because we don't know the value of K, in terms of K is negative or not. We've also got 3Q, and so it goes across and up, all right? So 3Q is going to go that way. And now we're ready to start resolving them. So, shift that back so I've got a bit of space. So if we're going to think about how we're going to do this, it's in equilibrium, everything's balanced. So for me, because the weight is only operating downwards, we can think about the horizontal components here. So if we do 3Q for a start, that's 3 lots of 16I, isn't it, plus 1.5J. So that's 48I plus 4.5J. Okay, that's the horizontal bit, the 48I. Likewise, the Kp, that's going to be K lots of 12I minus 5J. So it's going to be 12Ki minus 5Kj. Just make sure you're watching your signs here, because this is where you go wrong. So we know that these two together have to balance, out. They've got to. So we basically know that it wasn't right to write this going right. It has to go the other way because the horizontal components, if we do this now, horizontally, 48, which is that bit there, I, and then this, if you can put the I in if you want, okay, 48i, plus the 12k I have to equal 0, or 0i. And so what we end up with is 48 at 12k equals 0. So 12k is minus 48, so k is minus 4. Okay? If we do the same vertically, what we're now thinking is this element here, we've got 4.5, so going up, and again, it's all going to balance out now, right? So we've got 4.5j there. Then we'll think about this bit here. So we've got minus 5k j. I wrote it going down there, didn't I? But obviously I now know that k is minus 4. So minus 5 times minus 4 is plus 20. And that's the key thing. So I know that's also operating up because my 4 should have been going up that way. So plus 20j, they've got to balance out with the pure element was operating downwards of this w. So they've got to balance that out. So rather than sort of put it equal 0, we can put that equal to w, or whatever w is. And w is going to be in terms of j as well, isn't it? So we end up with 24.5 as the element there. And obviously we know that now the w bit is going to balance that. So weight has to be equal to 24.5 there. But we've got to make sure we read the question because it's asking for the mass. And so what we're saying is weight, which is mg, is equal to 24.5. If we're taking g as 9.8, and so therefore in order to find the mass, we've got to do 24.5 divided by 9.8, which gives me 2.5. Ah, nice answer. 2.5 kilograms. So there's a little bit of work for you to have a look at, okay? I will upload that now, and I will see you soon. Send the invites, and I'll see you next week. Okay, take care, guys.